good. Now we go to a very confusing part, but I have been paving the road for you so that it won't be confusing if you follow what we have said earlier. We want to figure out the type of feedback, right? So this one is also something you need to talk to people when you start using it on the standard, on the definition. For example, what type of feedback is this? So there are two ways to name it, right? Or first, I call it first way. First, maybe, how about let's call it first method. So, okay, so actually before that, let's understand this circuit first. What is the input to the whole circuit? Input to the whole circuit current. Let me be clear, right? Inputs to the whole circuit. Okay, so it's the whole system, right? It is current. What is the output from the whole system? Voltage, right? I know it is very easy, but I'm sure that some of you do it wrong in the exam if you don't follow this trivial stuff. Okay, so what type of amplifier? Thank you. I make it very clear. It is whole circuit. So this is a trans impedance amplifier. Fine, right? Now then, of course, then you clearly will see that, well, input is here, output is here, and I have something here. This is the feedback, right? So now you distinguish the feed forward and feedback, right? So let me ask you, what is the input to the feed forward? Again, very easy. Current, right? And the output of the feed forward? Voltage, right? And the type of the amplifier for the feed forward? Again, transimpedance. So you see that the type of amplifier is still the same as the open loop one, which makes sense. I make a very powerful amplifier, I add a feedback to it, I still want my amplifier to behave as the original intention, right? Because I create R0, I want to make a transimpedance amplifier. If you hook up a feedback, you make this becomes a transconductance amplifier, then defeat the purpose, right? Good. Then let's look at this. What is the input to the feedback? Voltage. Very good. And then the output to the feedback, what is that?
Well, you mean the entire feedback loop? The feedback loop to the input?
The feedback amplifier, what is that? Okay, K doesn't mean it is dimensionless, right? Just like it, so K doesn't mean it's unitless. Okay, it can be anything.
Well, as an output impedance, which would indicate that it's outputting current. If it's outputting current, and once it goes back to R naught, it'll be equal.
So think about this. What is the purpose of this feedback? Let's say it's a negative feedback. What is the purpose of the feedback? To do a comparison, right? Yeah. So in this particular case, so-called comparison I showed you earlier, for voltage is I subtract the voltage. For current, I subtract the current, right? If this is current, right? How does it provide the feedback to the feed forward in this case? By stealing away the currents, right? Make sense? Yeah, if it's positive, then you just provide more current. Yeah. So what is the output of this feedback? Yeah, it needs to be current, right? Because the purpose of the feedback is that you give me a signal. Here is current. I want you to reduce the strength of this signal. So after all the mechanism, it must be that you take away my current. And that means your output is current, right? Output can be negative, right? The direction here is going into there, being positive. Is this okay, this concept? Yeah, so this is the current. In that case, what is the type of amplifier that we have
But it's the, are we
for feedback?
are not from feedback. We're just evaluating it up until the input.
No. So what do I ask you? What is the type of the feedback circuit? Okay, I see why you're. I'm not talking about the feedback of the whole thing. I'm asking one is feed forward and then the feedback amplifier. Yeah. So what is the type of feedback amplifier we have? Now, amplifier can have a less than one gain. Transconductance. Why? I good. So do you kind of seeing that they are opposite to each other? Which is supposed to be the case, right? Because my output is your input is my output. Then, of course, the gain will be one, the units will be the reciprocal of the other, right? Okay, so this is just the first way to take a look what this look like, right? And then how do we call this amplifier, right? Naming. Right, this you will see in the midterm for sure. I already have my midterm paper, not midterm, I mean final. I already have that ready, so you better understand and do the assignment. Right? Not this question, of course. Naming, right? So we have two ways. One way is that we name based on the input and output of the feedback circuit, or let me call it feedback amplifier. What is the input to this feedback amplifier? Voltage. And what is the output of this feedback amplifier? Current. So this is a VI feedback, voltage current feedback. That's it. Where this is so simple, right? Everyone can understand. But the point is, it's so confusing that you might mess up if you don't look at this. Like the first naming method is that I look at the feedback circuit only, feedback amplifier only, input to output. That is how we call it, right? Now, I'm not going to give you partial credit in the exam if you put IV, okay? Because there are only 4 combinations, V, I, IV, VI. So you need to get it right, okay? No, but if you put VV, maybe I give you partial credit. I will do that, actually, usually, yeah. But just don't make this mistake, right? Because no more room for you to change. The second one is based on the connection of the whole circuit, right? Because we're talking about the type of feedback, I won't talk about the feed forward. I either only look at the what feedback amplifier I have, or how the whole circuit is hooked up. Okay? And again, I will start. So here, let me just emphasize, right? This is the input. I start with input. This is the output. Look that this is the input of the feedback amplifier, output of the feedback amplifier, right? So for this one, what I'm going to do is to use the word shunt and series. Shunt means parallel. Series means series, right? So this circuit, it is called shunt series feedback also. Okay, and why? Again, because this is the input to the whole circuit, because I'm talking about the whole circuit. The input here, you have a parallel connection because you need to steal away the current. It needs to be parallel. And we discussed this earlier already, right? Current feedback needs to be parallel for comparison. for voltage feedback need to be serious because you want to subtract the voltage. You need to be serious. Make sense? And then this one. Yes. Can you continue?
Since the output is a voltage, and we're trying to split it up, it has to be a series connection.
Right, because the output is voltage. So I'm wrong. Actually, I'm wrong. What?
Shouldn't it
What
be
should
series shunt?
I say the wrong thing? Completely wrong, right? No, shunt is correct. What is the second one? I did not look. Now when you say this, I realize I'm wrong. What should be the output? Should it be, is it a series or parallel connection? Parallel. Right? You just look at the drawing, it is parallel. Right, so I'm sorry for that. So this is a shunt-shunt feedback. Why? Because the output is voltage. In the output, what do? Do you do comparison or do you do sensing? You sense it, right? So you measure the voltage, you use parallel, right? Just like the voltmeter, you just put it there, right? So this is shunt, right? So you see that it's easy to make mistake, right? If you are not careful about this. If you want to be super careful, you can draw this circuit, all the 4 combination in your cheat sheet. But I'm not testing this. You know I'm going to give a circuit with transistor. So if you don't understand why this is called shunt, then you won't be able to do it, right? But again, it goes back to the very basic thing I mentioned earlier. Because this is a voltage, that's why you need to sense it in parallel. This one is a sensor, is the input to the feedback amplifier. So that's why you sense it in parallel, right? So any questions? Yeah. Which one? Say again. Oh, thank you. Yeah, thank you. Thank you for helping the student who did not attend the class. Right. Thank you very much. Yeah. So be careful about this. Okay. Okay, good. So if that's the case, then we are going to have something. Let me try to make sure I did not make mistake. Otherwise, voltage. Yeah, this is voltage current feedback, shunt-shunt feedback. Okay, that's correct. So then we can jump to all the 4 different types of feedback, right? It may be a little bit confusing, but you just do what I just told you. Okay, so he said it is voltage. No, not feedback. Yes, I want to know the amplifier first. This type, what type of amplifier is this? We call it voltage amplifier, right? Input is voltage, output is voltage. Okay. What type of feedback in terms of the voltage and current naming? It means I want to know what is the input and output of the feedback amplifier. What is that? The input is, so I deliberately put input here for those who don't watch the video and only read the slide and do it seriously should find that it's very strange. I put input here, why the output, I put input, right? But all those attending this class and watch this video know that I'm talking about the input to the feedback, right? So this is voltage. This is the output. So this is also voltage. And the reason is just because my input is voltage. When I do the feedback, I'm doing subtraction. I need to use voltage to subtract a voltage, right? So because of this, this is called voltage feedback. Okay. How about from the whole circuit perspective, connection perspective? This is the input of the whole circuit, right? What type of connection we have here? Series. Sometimes you might not be able to see it easily. Then you ask yourself, I want to do subtraction on voltage. What should I use? Series, right? Good. So the first one is series. Then how about the output of the whole circuit? You want to measure shunt. So this is series shunt feedback. Let's also talk about the units. Maybe I should do that earlier. What is the unit of A0? He said no, right? He shake his head. Unitless, right? So I can just say this is voltage divided by voltage, which is still unitless, right? But I just spell it out. What is the unit of K? Also V over V. Which makes sense. I have something comes in, the output doesn't change the unit, and then I go back, of course, doesn't change, and that's why you can subtract me. Right? If it is changed, you cannot subtract voltage from a current or current from a voltage. Right? This is for you to cross-check. Okay. So let's continue on the right one, right top. What is the what is the input and output of this circuit? Input is what? We just discussed. Of the whole circuit? Current. Right? What is the output? Voltage. So what is the units of the feed-forward gain? Yeah, what's the unit? Okay, ohm, right? So you can say V over I or ohm, right? How about for K? What is the unit? Good. You are all correct. I over V, 1 over ohm, Siemens, whatever, right? Again, this makes sense. I have current input, output is voltage, then you convert back to current, right? This is just a multiplication. V over I times I over V give me 1. I need to go back to current to do subtraction, okay? So you already told me that this is a trans impedance amplifier. And you also mentioned that, you did not, but we studied earlier, what type of feedback is that in terms of voltage? In terms of feedback amplifier. Voltage, current. So this is a voltage, current feedback. Thank you. Voltage, current feedback circuit. In terms of the connection of this whole circuit, this is in, this is out. It is what? Shunt feedback. Okay, good. Right, let's continue just as a practice. On the lower left, what type of amplifier is that? Transconductance. Because the input is voltage, the output is current. So the unit is, for GM is I over V. And for K is V over I, right? Again, they need to go back to unit. And that's why you can have 1 plus Ka. Have you ever thought about that? Right? Ka needs to be unitless. Otherwise, you cannot add to 1. 1 is unitless. Right? So many things for you to cross-check. Then, in terms of the feedback, this is the input to the feedback amplifier, and it is a current. And this is the output of the feedback amplifier. The output is a voltage. So what type of feedback is this? IV. Current voltage feedback. Okay. Now from the whole circuit perspective, what type of amplifier is this? Feedback is this? Okay, so one say Shunt-Shunt, one say Series-Series, right? So maybe this is very confusing. Then you go back to physics. What are you subtracting for the input? Voltage. How do you do voltage subtraction? In, in series, right? So you can see that indeed it is in series connection, right? But how about the output? But what are you doing? Are you doing sensing or comparison or output? You are sensing. Here, are you sensing or talking about this part, not this part, right? Are you sensing or doing comparison? Sensing, right? So when you're sensing means you're measuring the current. How do you measure a current? Do you use series or parallel? Series, right? And then you look at it carefully. Indeed, this current will go out and then go into here, and then here, there's no branching. So indeed, it is series. So this is a series feedback. Make sense? This is confusing if you just look at the connection. Really, right? That's why you need your previous knowledge. You need to understand what you are doing with this circuit, right? So this is a series. Am I doing something wrong again? Yeah, series. I just my cheat sheet is messy. Okay, so how about I give you 1 minute, right? Try to think about what it is for the last one. How do you call it? What type of amplifier? What are the units? How do you call it in terms of IV feedback or the series shunt feedback? Right. Again, it is confusing. You try to correlate to.
Maybe. So we can.
Okay, so what type of amplifier is this?
Current.
Thank you. Current amplifier. So what is the units of AI? Unitless, because it's current divided by current. And how about the feedback? Also I over I, unitless, which makes sense, right? And then if I look at the inputs to the feedback, is it a current or voltage?
It's a current.
Current, because it's current feedback. Current amplifier. It's a current amplifier, right? And the output, the same is current, right? So this is a current feedback configuration. Okay, and how about from the whole circuit perspective, right? What is the input connection? It's a shunt, because you are trying to do current comparison, subtraction, right? So this must be shunt. And how about the output? It's series, because you're trying to sense the current, right? Is this okay? Okay, good. Then let's move forward. So we will pick two of them to have a deeper